Continuing on from the last lesson, let's reverse the process of drawing a 3D object from 2D projections and do it the other way around. So we have this 3D object that we want to find out the front, side, and top projection for it. So let's start with the front projection. First thing to do is to extend the front face outward using the vanishing point. I also extend the lines from the other vanishing point to close off the whole shape limit from all sides. Now that we have the rectangle that encloses the whole shape, we can push it outward away from the object. Now we can add the interior details for the object, like the ledge on the top and the platform on the bottom. After drawing the surrounding shapes, we can add the slope between the top and bottom by connecting in between them. And this is basically the front projection of the shape. Let's now do the side view in the same way. First projecting the whole bounding rectangle for the entire shape. Then we add the details inside, starting with the top ledge and the bottom platform. Finally adding the slope in between, which will look like a rectangle in this view. Let's do the top view now by extending the vertical lines for the whole shape and draw the bounding rectangle for the whole object. What we will see here is the top ledge and the connecting slope in between the ledge and the bottom platform. The only detail we can add is the hidden line between the back wall and the top ledge, which will show up as dotted line in the middle of the top ledge. So let's now reverse this process by moving these projection plans into 2D and try to reconstruct this 3D object with these 2D projection plans. The first step is just to look at the projection plans and study them. Take your time and understand what we are looking at. Then pick up one projection and start from it. Let's start adding the L shape in the front. Once I decide the width of the L bridge, I can rotate it around using the diagonals. Then I add a little extra for the ledge on top. Finally, I extend this shape all the way to the back using vanishing points, while using the guidelines from the L shape in the front. Now that we have the surrounding shape, it's time to add the slope in the middle. To get the slope in the middle, I find the center for the bottom platform and then divide 1/2 twice till we get the quarter of the distance on both sides of the center line. From there I can project these lines back and up toward the ledge and pinpoint the location of the slope there as well. Finally, I connect in between the top and bottom points to get the slope in between, and connect its base back toward the wall in the back. If the slope looks too thick, we can simply shorten it a bit, since we don't have the exact dimensions. Next, I add the line weight and clean up the drawing and call it done. Let's do a couple more examples, alternating between using 2D projections to draw a 3D object and vice versa. So here we have 3 different 2D projections, but this time with added units. So we no longer have to guesstimate. We now have to observe the unit drawn in the 2D projections and apply it to the 3D object. So let's start first with choosing the easiest projection to start with. So I'm going to start with the side view since it's the easiest part to start with and the most representative of the object. Now the side projection is 8 units long, so we have to divide the left side of the box into 8 equal parts. We can do that by drawing the horizontal line, connecting it to the horizon line at a random point, and divide that area into 8 equal parts and project it back into the horizontal line. Now we have 8 equal parts drawn on the box. In the front side we have 5 units, so let's copy 5 units to the right and project it back to the horizontal line and mark the 5 units on the front of the box. Finally, we have 5 units in height, so to do that, we simply divide the vertical line of the box into 5 equal parts and connect them to the vanishing points on both sides. With all that done, we can start projecting the side view on the side of the bounding box. We start with the L shape. Once I draw the L shape, I move on to the front view and the top view to check the depth of the L shape in perspective. Is it all the way to the back, or is there a space in between? If we look at the top view, we can see that there is a space in between, which is about 2 units wide. So let's stop the first part at 1.5 units, as we see in the top and front view, and continue the same line at the end, also at 1.5 units. From the top, we also have a space in between the top ends, which is 3 units wide. We can project the top for now all the way to the back, and move on to the base of the shape. The body of the object is 6 units long according to the top view, so at the 6th unit, we can project the lines all the way to the back as it is in the top view. Then, 2 units in, we can draw another line to end the space in between the 2 legs of the object. Finally, I can close the shape at the end and draw the end of the back side. Let's now hide all the lines so we can have a clearer look to what we got so far. We have the base done and the back. The only thing left, as we can see in the projections, is the space in between the top pillars. We know from the side and the front view that it's 1 unit high, 2 units long, and 1 unit deep. with 3 units in between. So let's bring the measurements line back and mark the placement of the 2 pillars and start curving the space outward. This is like sculpting done by drawing and by following the blueprint of the projection view. Now we can curve out the space. The shape is almost done. Let's do final checks on the object. By checking the projection views, I can see all the details have been drawn. If you look at the dotted line in the side view, these are the holes that will show behind or in between the object. So the bottom one is for the space between the legs of the object, and the top one is for the space between the pillars. And all of them are in their right position and correct units. All you have to do now is to add a better line weight on top and finish up the object. And this is the final shape, done in perspective using 2D projections. We are now doing more and more complex objects in perspective, thanks to all the practice we had in the previous lessons drawing all these boxes. Hopefully now it's paying off, and the more we do them, the more complex objects we will be able to draw in the future. In this next example, we have a 3D object all done, but we need to find out the 2D projection for the object without drawing it on top of the object like we did before. Let's start with an easy example. This object is a simple shape being extruded backward, so the most detailed projection will be in the front view, since it has the whole shape of the object in it. We also have 4x4 units on all projections, meaning that this is an equal cube. So let's start drawing the shape's front projection. Seems like each of these ins and outs are 1 unit wide and 1 unit long. So let's basically copy the shape on the front projection. And it's done. Very easy process. Other examples will be trickier, but let's move on to the side view. The side view have 1 unit rectangle in the top, 1 unit as a whole, and 2 units for the body. But there's also a hole in between the top and the legs. But the top hole is on the same line of the top rectangle, so it won't show up in this projection. But the bottom one is in between the 2 unit long leg, so it will show up in the middle as a dotted line. The hidden holes or spaces won't show if they are on the same line that shows on the side view. It will only show in between the side lines. From the top, we have 1 unit rectangle on both sides with 2 units for the triangle. But from the top, the triangle will look like a simple rectangle with a line in between. So basically, the projection will be a square with 3 lines. There are holes and shapes going in and out, but all of them will fall on the same lines that we have on the top, so they won't show on the projection. And this is it. These are the 3 projections for this object. You can recreate this object using these projections and get the exact same result, the object right here. You can actually try it if you want. Delete the shape and do it from the projections plan you just did and see what you get. But for now, let's move on to another example where we draw the 3D object from the projections plane. A little more complicated shape than before. We have 3x7 units side projection, 3.5 by 7 units top projection, and 3.5 by 3 units front projection. The most visible projection that describes the shape is the side view. So let's start with that one. We need to divide the box from the side into 7 units and vertically into 3 units. Once I have all the divisions drawn on the side, I can copy the side projection here. Anytime I need to divide a unit in half, I can just eyeball it or use diagonals to get the center right away. Now it's time to draw the depth while observing the top and front planes. So let's divide the front side as we see it in the projection plan. The sides of this object go all the way to the back, as we see it in the top view. So let's draw it there. The main body of the object is basically three sections: the side section, a middle bridge, and a copy of the front shape in the back. So let's extrude the side shape 1 unit to the back. Next, I add better line just to see what we are working with. Okay, let's add the back part now, which is the same as the front shape but 1 unit at the back. So I can use the side shape we did to draw the one in the back. Next, I draw the bridge in between, which is 1 unit up and 1.5 unit in width, as we see it in the front view. And we can see from the top view that the bridge is 4 unit wide, stopping at the lower platform. Okay, the lines are getting busy here. So let's redraw what we got so far and hide few lines that we don't need. Okay, this is the shape we got so far. The only thing left is the hole in the front going all the way to the back, as we can see from the dotted line in the front and top views. The whole side is 1 unit and is half a unit above the ground and a half a unit below the bridge level. As we said before, if you want to know the center of the unit, just do a diagonal as we did before and you get the center right away. Now that I have the bounding rectangle, I can draw the ellipse right there. And we are almost done. So let's take a minute to check all the projections from all the sides and check if our work is correct. Then I move on to drawing the final line weight and finish up the object. And this is it, the object is done. A very complicated object made easy using projection plans. Next example, we go back to finding the projection plan out of a 3D object. These geometrical puzzles are really fun to do, and you can find a lot of these shapes online, so pick as many as you can and either draw the object again or find its projection planes. The good part of this is once you get the projection plans, you can redraw the object in any perspective you want, something we're gonna do later on. So you are already changing the reference into different perspectives. This here is the building block to draw and change the reference image into different designs and perspectives. So let's study this object from all sides and see which projection location should we start with. We have a pyramid with a cut on top and a box in the sides with holes on each side. The shape is 2 units in the front, 8 units in the side, and 4 units high. It seems like the box is 2 units high, so let's start there. It's also 2 units wide, so we can draw it first. The pyramid will look like a normal rectangle from the front view, with a hole that is 1 unit in between the top tips. Finally, the hole is 1 unit in the center, but it's hidden, so it will be in dotted line. From the side, we have the pyramid 4 units wide and 2 units for the box on each side, but to be sure, let's draw a horizontal line and divide it into 4 equal parts and see where these parts are in comparison to the object. We can use this if we are not sure how accurate the measurements are. So as we can see, the pyramid is indeed 4 units in width with 2 units for the box from each side. Now the boxes continue from one side to the other, so I'll draw the whole thing as one rectangle. From the center we can draw the tip of the pyramid and 2 units on each side, and from there it will be the base. I'm going to do a quick measurement for the holes. It's in the center, in between the first and second division with a width of 1 unit. So we can draw the dotted lines there on each side. Finally, the top hole is half a unit down from each edge of the pyramid. I can use diagonals again to find the center of the unit quickly and draw the dotted line there. Finally, for the top view, we will see the pyramid as a rectangle with a large rectangle inside for the box. So let's draw the box first from one side to the other with 2 units in width. Next, the pyramid with 4 units in width and 3 in length with the line in the center for the tip of the pyramid. Now in the middle of that tip, we have a hole that we can measure its width from the side view and draw it in the center with 1 unit length. The box is going through the pyramid from one side to the other, so it will continue going in as we see it in the side view, till the third unit, and then the line will become dotted as it goes inside of the pyramid. Finally, the holes are in the center of each square, so let's find the center of the square and then divide it into 4 equal parts and draw the rectangle in the inner smaller rectangle in the center. That will be our hole in both sides. And this is it. These are the projection planes for this shape. No matter how complicated the shapes get, we can still manage to take it slow and understand how each projection will look like if we were looking at it in the 2D fashion, or straight ahead from one side. Okay, we can do one final example and draw a 3D object from 2D projections. It will be the most complex object we drew so far. So let's dive in. So here we have a complicated shape with lots of slopes and intersections here and there. I went ahead and drew the segments unit on the box already, so we start right away with the drawing. You should be able to do the divisions on the box by heart by now, since we did it a lot in the previous lessons and examples. So let's decide which side we start from. The side view seems simple. So let's start with the hole in the top left, 1 unit wide and half a unit in height. Next, we move on to the slope. The first slope hit the 1 unit corner in the bottom, but the back slope seems to be behind. If we shift the top view, we can see the slope we are looking at is in the center of the object from the front. And if we shift the front view, it seems like it's sitting on a triangle. So you have to check all 3 views at the same time, before adding any lines there. So from the top view, this line will go toward the front view at a 1 unit mark. From there, it will go the same way to the other side. So let's draw the rectangle next. Very straightforward, 1 unit high and 2 units wide. From a step, it will go as a slope to 1 unit in the top view, and from there it will go back to the side view. All this data is from the projection planes we are looking at. Every line I put down is from the information I'm reading in the planes. Now this object is symmetrical, so we will have the same shape on the other side. So let's go to the side view in the back and 1 unit down at the bottom, and finally connect it to the triangle in the front. So we got the front and the side view done. Let's now finish up the top view of the object. The holes are on both sides in the back, but with the solid object in between. Each hole is 1 unit wide, but the back end of it is on a slope, as we can see from the front view. So it's straight in the front and slanted in the back. So let's do the area in between and then close it in the back with a slope. The other side won't show, so it will be just a rectangle there. Finally, I connect between the front and the top to close up the object. The more you do these exercises and puzzles, the faster you will get solving them, and these are a lot of fun to do. Now all is left is adding the hole in the center, which isn't an ellipse, but more of a smooth rectangle. To do this, let's first draw the bounding rectangle, 1.5 unit in and 3.5 unit long, with 1.5 unit space on the other side. Once we have the rectangle, we can draw 2 ellipses on each side and delete half of them to get half of the ellipse on each side. So to do that, we need to find the rectangle surrounding each circle on each end. So let's divide a unit on each side and find the center for it, and draw the ellipse on each end. Once we have the ellipse, we can remove the interior half of it and connect it to the other end to get our smooth rectangle. I added a little line at the tip of the hole just to show that it's a hole, not to the ellipse on top. All is left now is to add the line weight and finish it up with some values on the shadow parts. And this is it, all done. A very complicated shape done fully in perspective using 2D projections plan. You can find these online as I mentioned before, and they are really fun to do. Most will be done in isometric views, but you can simply make projection plans for them and then redraw them in 1, 2, or 3 points perspective to get better at drawing things in perspective. The more you do them, the faster you will be, and the better your understanding for all tools and guidelines for perspective you'll have. Now, as I mentioned, there are other ways to draw objects in perspective, like freehand or using sections that we will explore later on. But for now, this is one of the methods to draw objects in perspective. Before finishing up this lesson, let's move on more advanced shape that we will eventually use when we draw the interior scenes. Drawing a staircase, for example. We can do it with everything we learned so far, but with a bit more information. There are a couple of ways to draw a staircase. Let's start with one of them. First, I draw the top plan of the staircase, where the whole stairs will fit in. Then I choose how high I want the stairs to be, basically drawing the bounding box for the whole staircase. Next, I start with the first step all the way to the back. This will set the height for the rest of the steps. Once I have the first step done, I will choose a point in a vertical line from the vanishing point to make the stairs go up on a slope. This will be the new vanishing point for the angle of the stairs. So I will connect the first step start point toward the new vanishing point, crossing over the top of the bounding box. I will do this for the top of the step and the bottom of it. Next, it's time to decide how many steps do I want. So I draw a measuring horizontal line and connect it to the horizon line at the end of the bounding box. Next, I divide the line into 9 equal steps. Now I connect them back to the same measuring point, dividing the right side of the stairs into 9 equal steps. From there, I draw the vertical line to divide the side face of the bounding box. Now it's time to draw the side projection of the stairs following the intersection lines between the vertical divisions and the diagonal line toward the vertical vanishing point. Once you connect the vertical line, you can extend it back to the horizon line to draw the top of the step. The step stops at the second angle line on the bottom of the step above it. Now that we have the full projection of the stairs on the side, all we have to do is to connect it to the other vanishing point to extrude it to the other side. We do the same thing we did on the right by connecting the steps following the guideline of the slope lines. Now we have so many lines. Let's add some of the lines we don't need and continue drawing the steps. We are basically done, but let's draw the final lines and draw the whole staircase in better lines. Finally, let's add some values. And it's done. Not very complicated, but we added something new, which is the vertical line on top of the vanishing point. This higher vanishing point can be used to draw angled lines, like the slope of the stairs or the cast shadow from the sun toward the object, something we will do later on. Let's now try drawing the stairs but using a different method. This one won't require any vertical vanishing points. Here I start with drawing one single step first. Then I replicate the height of the step upward to get the first edge of the second step and connect it toward the vanishing point. To know how wide the second step would be, I duplicate the first step width using measurements toward the vanishing point. And from there, I draw the vertical line for the second step. You can also use divisions for the whole staircase at once if you want as a third method. I do the same again for the third step. And then the fourth step, and so on. And it's done. Let's add the final outline and values. So this method is a bit easier if you don't want to go into vertical projections, but it's a bit slower than the first one. You can use it for a few steps, but if you have like 20 steps, it's much easier to use the first method to draw them all at once. And this is it for this lesson. It was a bit long, but with lots of good examples. Take your time with this one. As I mentioned before, it's only getting more and more complicated from here. So take your time and do as many examples as you can before moving on to the next lesson. And then, as I mentioned many times, we will have to eyeball the whole thing while doing all these calculations in our mind instead on the paper itself. And that's exactly what we will talk about in the next lesson. Eyesight, or eyeballing, or fanning versus technical drawing. All we did so far is technical drawing. But when you are doing ideas or concept art and need just a quick sketching, you won't be drawing all these perspective lines and correct angles. You will have to eyesight most of it. But we can't just do it blindly. We have to learn the mechanics of perspective first before shifting gears and doing all the work in our mind instead of the paper. So in the next lesson, we will start applying all we learned so far in an easier and more practical way that works for us as artists. But you should first practice all we talked about till you are comfortable enough to move on to the next stage of perspective drawing. Once you are comfortable enough, we can move on with eyesighting in perspective. So we'll do the freehand method first and then do both eyesighting and technical draw. And then we will mix and match in between the two methods on real-world objects afterward. So we'll do that in the next lesson. As always, if you like this lesson, feel free to leave a like. If you have any questions, leave them down in the comment section and I will do my best to answer them as soon as possible. To stay notified for future lessons, don't forget to subscribe and hit that notification bell. Thank you all for watching, and I will see you in the next lesson.